Yeah, hi all. Welcome to the Cognitive Learners. Yeah, today we'll short webinar on DRAM. DRAM. Okay, some of the students or some of the peoples are already know about advantages of the DRAM. Let's simply yeah, DRAM like that on card is present on the PCB just placed. Okay, that is one part, and second part is yeah, that is used as a temporary memory, temporary purpose, short time purpose. We use the storing purpose, short time storing purpose, right? That is simple theory concept. Okay, if you have any idea, if you have any idea about DRAM or DDR controller, it's both the Pushparag and Ayush. If you have any idea about the DRAM and DDR controller.
The idea about DDR controller, like
Yeah,
basically controller acts as the bridge between the DRAM IC and the processor or
yeah,
any other peripheral,
yeah,
which usually is master. So DDR is basically a double data rate where at high speeds data is sampled on both positive and negative edges.
yeah. Okay, 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 that's fine, that's fine. Yeah, Pushparaga, if you have any idea about DRAM or DDR controller.
Yes, sir. It is a technology.
Yeah,
Means it is a double data where we can send the data both positive and negative.
yeah,
Uh, it is used in all of the or SOC, SOC chips. We can use the data.
yeah, yeah. That's good. That's good. Okay. Yeah, you some of the knowledge already. Some of the theory concept you already done. Yeah. Okay. No problem. Yeah. Last question before starting to the last question. If you have any idea, the DRAM card is placed inside SOC or outside SOC. DRAM card.
Outside the SoC.
Any reason?
It's just a temporary memory and comparatively it is slower compared to the SoC. So to talk with the SoC, there is a cache.
Yeah.
So whatever data is present in DDR will come to the cache and then goes to the processor.
Yeah. Okay. 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 Yeah. No problem. Yeah. First, the today webinar topic is frequency and bandwidth calculation as well as addressing table calculation. Okay. Before going to the classes, I will give you a blueprint. I will give a blueprint how to the ongoing the next 1 hour how to spend that hour. Okay. Yeah. Let us assume these all are the DRAM chips. Okay, DRAM cards only. I will show one card. Okay. Yeah. This one DRAM card. In this card, just mention one storage that is 4 GB. 1 minute. Yeah, in this card one storage mention, right? 4 GB, 4 GB. Okay, this cross for next we will come this part. Okay, next, if you have any idea what is the 4 GB, what is this? That is the storage of okay, first I will explain scratch only. Okay, don't worry about that is the whole chip capacity. That is whole chip capacity, guys. 4 GB. Okay. Yeah, next I will give a small blueprint about the DRAM card. Yeah, simply in short time I will differentiate DDR3 and DDR4, guys. Okay. uh, Concentrate. Yeah, the left side part is DDR3. Okay, DDR3, and this side is DDR4. Okay, I will bifurcate two things. This is one. Let us assume this one DRAM 3 card. This one DRAM 4 card. Okay, on side or on the DRAM or the DRAM cards, small chip is present, right? Small chip is present. Small black color chips are present. Small black color chips are present. Next, one more question. One more question. You only see, guys. In this card, how many chips are present? How many chips are present? Four chips are present. Four black color chips are present. Right? Okay. I will show another one chip. Yeah, four, eight. Yeah, sorry. Eight black color chips are present. Yeah, next, this other class four. Okay, 1 minute. DDR4 cross. Okay. Yeah, listen, guys. Listen. In this DRAM card, only four black color chips are present. In previously, in this card, eight black color chips are present. Yeah, this is four. Yeah, labeling. This side four is present. Totally eight. Okay, in this card also four eight black color chips are present. But in this DRAM card, four black color chips are present. Four black color. Again, I will show one more DRAM card. In the DRAM card, 16 black color chip. That is crash 4. That is crash 16. Yeah, that one. Okay. DDR5. Yeah, count 4, 4, 8. 8. Yeah. Listen, this DRAM card. First one DRAM card. Let us count black color chips. How many black color chips are present? Totally 8. Offside 8 present. Another offside 8 present. Totally 16 black color chips are present. 16. Yeah, listen, count this. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this is ECC, error controller chip. Don't worry about that. Okay, let us count this 8 chip, this 8 chip. Totally 8, 16 black color chips are present. Okay, some of the DRAM card have 8 black color chips. Some of the DRAM card are 4 black color chips. Some of the DRAM card are 16 black color chips. Okay, how to identify this is in which way, or in which way the black color chips are mounted on a DRAM card? Anyone have any idea, guys?
No.
Yeah, okay. That is the main point. First, before entering to the okay, the Pushparag and Ayush told, yeah, sir, some of the idea of DDR controller. Okay, before going to the DDR controller IP design, first we aware about DRAM card. Aware about DRAM card. Okay, you only see the real time practical scenario. Okay, some of the DRAM card have four black color chips. Some of the DRAM card have 16 black color chips. Some of the DRAM card only 8 color black color chips. Okay, each have one advantages. Okay, let us that's next part. Okay, in which way we identify this is particular name is present, right? Particular name is present, definitely the particular name is present. The DRAM card have 4 black color chip, that is have one naming. The DRAM card have 8 black color chips, that is have one naming. The DRAM card have 16 black color chip, that's have one naming. Okay, sir, how to identify? Next, how to identify that name? That is next part. Okay, yeah, that is next part. I will see how to identify that. Okay, yeah. First, I didn't take in this time DDR3 and DDR4. Let us take one DRAM card. Okay, this both applicable for both DDR3 and DDR4. Okay, let us assume 64 pins are present. You assume next I will show you. Okay, that is 64 pins. Let us assume 64 pins are present. Let us assume, guys, these 64 pins are DQ pins. DQ pins, data pins. Okay, data pins. Yeah, this is DRAM. This is DRAM code. Yeah, to control the DRAM card, controller is present, that is DDR controller. Next, this side CPU. Okay, this side CPU. Okay, the CPU send maximum 64 bytes of data. The CPU send 64 bytes of data. Okay, that is fixed. 64 byte of data maximum. Minimum we can possible to share 8 bytes of data also. Okay, the DDR controller inside the DDR controller some logic is present. Okay, finally the 64 bytes of data emerge from the DDR controller. Okay, but the Ayush initially told it is work both neg edge and pose edge, right? Neg edge and pose edge. Okay, I will write on the initial clock. 1 clock. Initial clock. Each clock, each clock edge can able to send the data. The DDR is both work on neg edge and pose edge, right? Okay, we send this 64 bytes of data. Okay, in each clock, in each edge, we can possible to send 64 bit of data in each edge. How many edges are needed, guys? Anyone? You only calculate. Finally, from the DDR controller, 64 bytes of data we can send from the DDR controller. Okay. Finally, the each edge 64 bit can able to send. 64 bit can able to send because 164 pin only present. 64 pins only present. 64 pins only present. Okay, in each edge can send 64 byte of data, 64 bit of data. In this side 64 bit, suppose this side 64 bit, this side 64 bit, 64 bit, 64 bit, 64 bit, 64 bit. Okay, 1 2 3 4 5 6 7 8. How many clock cycles are needed? Anyone guess? How many clock cycles are needed?
4.
4. 4 clock cycle is enough to send 64 bytes of data, because each edge can send 64 bit of data into 8, nothing but 64 bytes. 64 bytes. Okay, each edge nothing but neg edge and pose edge. That is the first scenario. Guys. Okay, next we come to the DDR part. Sorry. DDR card. Let us assume 4 categories of DRAM. Inside one DRAM card, I have 4. Let us assume topology. Cross 8, cross 4, cross 16 concept. Cross concept is present in DRAM card. Whether your DRAM card is cross 8, your DRAM card is cross 8. This is applicable for both DDR3 and DDR4. Okay, whether your DRAM card is cross 8, in that how to calculate, this is this slide is teach you how to calculate. 1 minute. Yeah, in this slide teach you how to calculate how many black color chips are present, or based on cross. Initially we saw, right, in different DRAM card I have different number of 8 black color chip, 4 black color chips, 16 black color chips. How to identify? Okay, first we take 8 chips. First we take 8 chip. Okay, first we take 8 chip, guys. Okay, whenever your DRAM card have 8 chip, whenever we DRAM card have 8 chip, in that time 64 pins are available, right? 64 pins are available, right? On the above DRAM card mention cross 8, cross 4 or cross 16. Okay, I will clue one point, guys. Cross 8, 8 black color chips are present. 8 black color chips. Whenever your DRAM card is cross 4, 16 black color chips are present. That black color chips is called module, chip module. Okay, this is called chip module, chip module. Okay, whenever your DRAM card is cross 16, in that time 4 chips are present on the DRAM card. 4 chips. That is the compulsory, or this is applicable for both. Yeah, both DDR3 and DDR4, guys. Okay, let us assume 4 black color chips, sorry, 8 black color chips. 8 black color chips are present. You only tell this is cross 4 or cross 8 or cross 16. Hello, I am audible, right? In this time, the DRAM card have 8 black color chips. The 8 black color chips nothing but cross 8 or cross 4 or cross 16.
Cross 8.
Yeah, cross 8. Definitely cross 8. In that time, how these 64 pins are divided? In which way the 64 pins are divided, guys? Okay, next one more scenario. Whenever your DRAM card is cross 8, in that time, each location each location can be store 8 bit of data only. Can be store 8 bit of data only. 8 bit of data only. That is compulsory according to JEDEC specification. Okay, when whether your DRAM card is cross 4, in that time each location can be store only 4 bit of data. Whenever your DRAM card is cross 16, in that time each location can be store only 16 bit of data. 16 bit of data only, guys. Okay, this is understood, guys. If you have any doubt in this part, next we'll see how the 64 pins are divided. Next we'll see. Okay, this scenario will understood, right? If you have any doubt in this part,
No doubt.
yeah, that is the basic thing. Okay, next we'll see one more slide. Next we'll see. Next we come to the cross 8. Next come to the cross 8. In cross 8, how many devices are present on the chip, on the DRAM module?
8.
8. Yeah, definitely 8. 8. Inside this, 64 pins are present. Okay, right? 64 pins are present. Okay, each module 8 pins are connected. 8 pins. This also 8 pins. Let us assume this is 63 down to 0. 63 down to 0, nothing but 7 down to 0. The 7 down to 0 pin is connected to, let us assume this is chip 0, chip 1, chip 2, chip 3, chip 4, chip 5, chip 6, chip 7. Okay, the 7 down to 0 pin is connected to chip 0. In that time 8 bit, 8 bit of data. Okay, same way 15 down to 8 is connected to chip 1. In that time 8 bit. In the same way 63 down to, yeah, 58 or no, yeah, 57. Yeah, this is connected to chip 7. In that time also 8 bit. Okay, yeah, 1 minute. Yeah, yeah, okay, this way the 64 pins are divided 8 pins. 8 pins in each, 8 pins connected to each module in cross 8. In cross 8. Okay, next we come to the cross 4. Next we come to the cross 4. In cross 4, how many devices are present?
16.
Yeah, 16. You only tell in each chip how many pins are connected?
4.
Yeah, 4. Definitely right. 8 chips are present. Yeah, sorry, yeah, 16 chips are present. This is crash 4. This is crash 4. In my side, 64 bit data pins are present. 64-bit data pins are present. In that time, 4 4. This is connected to chip 0. Same way. Chip 0, chip 1, chip 2, chip 3, like that. Until chip 15. Chip 15. Same way. Okay. Same way we applicable for both in cross 16 also. You only tell in cross 16 how many devices, how many chip modules are present on the DRAM card?
4.
Only 4. Only 4, guys. Okay. Next, I will show. I will take either cross 4 or cross 16 or cross 8. How to data will store by using clock cycle. Okay. Yeah. For better, we take cross 8. Cross 8. Cross 8. In cross 8, 4 chips are present, right? 4 chips are present. Yeah. I take a 4 clock cycle. In this clock cycle, 64 bit. In this clock cycle also 64 bit. In this clock cycle also 64 bit. In this clock cycle also 64 bit. Yeah, this is only applicable for DDR3 and DDR4. Each clock gets can able to send 64 bit. Whenever we come to the DDR4, DDR5, in that time channel concept is present. In that time, each at 32 bit. Okay, don't worry about DDR5. Okay, just 1, 2, 3, 4, 5. Yeah, that is complete. Yeah, okay. Yeah, in this time, from the CPU, 64 byte of data is present. 64 byte of data, but each clock gets can able to send 64 bit of data. Finally, all data is completely 64 bytes. 64 bytes. Okay. Yeah. Next, whenever first clock is enabled, first stage is enabled. In that time, the 64 bit of data, the 64 bit of data, the first 8 bit is connected to chip 0. Next 8 bit is connected to chip 1. Next 8 bit is connected to chip 2. In the same way, 8 bit are connected to each chip. That is first edge. In the second edge also same thing. Third edge also same thing. Until completion of 64 bytes of data, same thing will happen. Same thing will happen, guys. That is the how to store data or 64 bytes of data in each chip module. Same way only in each in cross 4 also, cross 16 also, guys. If you have any doubt in this part,
No.
yeah, the other than Ayush, if you have any doubt,
No, sir.
yeah, that is good. That's good. Yeah, that is the outlook of DRAM card. That's the outlook of DRAM card. Yeah, next I will show practical example. You want to tell it's class 4 or class 16 or other than. Yeah, take this example and you only tell this is cross 4 or cross 16 or cross 8.
Cross 8.
Yeah, cross 8, definitely cross 8.
Cross
Yeah, yeah. Next, labeling I will show. Yeah, inside label is present, right? In the, yeah, on the label cross 8. Cross 8 nothing but 64 divided by 8. How to identify number of chip? Number of chip formula is number of chip. How to calculate number of chip? Number of chip is equal to number of chip is equal to 64 divided by cross. Either cross 8, 64 divided by 8. Either cross 16, 64 divided by 16. Either cross 4, 64 divided by 4. Okay, same way. Okay, yeah, that all are cross 4 only. Sorry, cross 8 only. This, uh, yeah, this also cross 8. Yeah, this also cross 8. Yeah, yeah. Next, yeah, labeling. I will show one more diagram. DDR. Oh, cross 4 is, yeah, that other cross 4 only. Cross 8 only. Yeah, okay, don't worry. Yes, cross 4 nothing but this out where, yeah, this is cross 4. That is cross 4 because 16 chips are present. Yeah, this is cross 4. This is same. Yeah, around, yeah, 4 4. Yeah, that is ECC. That cross 8. That is cross 4. Again cross 4. Cross 16. In the cross 16, only the 4 chips are available on the DRAM card. That is where cross 6. Yeah, same way, we can easily identify either cross 4 or cross 16 or cross 8. Okay, that is the first, the introduction part of the webinar of frequency calculation and next part of the webinar. Okay. Yep. Next, frequency calculation and bandwidth. Okay, before entering into this concept, we will brief explain theory concept of how to identify cross 8, cross 15 concept, cross 4, cross 8 and cross 16. The DRAM card is cross 8. The DRAM card is cross 8. That card have 8 devices, 8 chip, 8 device, 8 chip or 8 chip. That, yeah, that card have 8 chip, and each chip can store, and each chip and each location. Okay, better, each location can able to store 8 bit of data. 8 bit of data. In the same way, the DRAM card is cross 16 or cross 4. That card have 16 chips, and each location can able to store 4 bit of data. Next, the DRAM card is cross 16. Cross 16. That card have 4 chips are present. That card have 4 chips, and each location can able to store, can able to store 16 bit of data. 16 bit of data. Okay, that is the cross concept, DDR cross concept. Okay, next we jump to go to the frequency calculation and bandwidth. Frequency and bandwidth concept. Frequency and bandwidth concept. Okay, I will show the frequency range of DDR3 and DDR4. Okay, first we concentrate on DDR3. That is the DDR3 frequency range. That is DDR3 frequency range. That is DDR name only. DDR3 800, DDR3 1066, the DDR3 one 333. This is this column. This column is DDR name, DDR card name. Okay, this is PC versions. Okay, that is PC version. That is the frequency 400 to 1066 megahertz. The DDR3 working what is the frequency range? 400 to 1066. That is the frequency range. That is frequency range. Okay, next transfer or mega transfer, you can suitable. Okay, transfer per second. How to transfer per second? That is the transfer per second. Next, we only so how to calculate that frequency, which way to identify frequency and transfer rate, data rate, and bandwidth. Next we'll see. Okay, okay. First I will show one card. Okay, same way we move. Okay, yeah, that is a DDR3 1000 mega 1600 megahertz. That is for that is a mega transfer only. That is not a frequency. That is not a frequency for labeling. For mention 1600 megahertz. But DDR3, what is the last frequency range of DDR3? 1066. But in this time, that is 1600. The 1600 frequency DDR4. DDR4 frequency range is 800 megahertz to 1600 megahertz. 800 megahertz to 1600 megahertz. But DDR3 frequency range is still from 400 megahertz to 1066 megahertz. Okay, no confuse. That is transfer rate, data rate. That is data rate, mega transfer per second. Okay, yeah, we'll take one card. Next, I will show. Okay, yeah, we'll take this card and explain how to calculate frequency, how to calculate bandwidth, that all. Okay, yeah, that is 4 GB cross 8, DDR3 cross 8, right? 4 GB cross DDR3 cross 8. Yeah, next take example. That example is 4 GB DDR3 cross 8. Okay, 4 GB cross 8. Okay, one bracket, one number is present, that is for 1600. The 1600 is data rate. The 1600 is data rate. Don't confuse, guys. Mega transfer per second. Mega transfer per second. That is mega transfer per second. Okay. Yeah. Next, I give one three formula how to calculate frequency. That all. The frequency is simple. Frequency is equal to the reciprocal of time. That is the frequency. Next one is transfer per second. Transfer per second or transfer rate or data rate. Transfer rate. The transfer rate formula is equal to frequency into 2. Why frequency into 2? Okay, the frequency is related to one clock cycle, right? Both neg gates and posits. Okay, suppose, yeah, that is the one clock. That is the one clock. That is the clock frequency, right? That is the clock frequency. But in this time, data, in particular in DDR time only, the transfer rate is the double of frequency. Whenever we go to the APB protocol and AXI and AHP, HI, AS protocol, these all are related to the frequency is 1600. Yeah, the data transfer also 1600 mega transfer per second. But in DDR, multiplication of 2, because this work on both negates and posits. This work on both negates and posits. Due to that reason, the frequency is the double of the transfer rate or data rate is the double of frequency. Okay, that is the reason. Okay, don't confuse. Yeah. Next, uh, third one formula is bandwidth. The bandwidth formula is equal to transfer rate into uh, how many bit or which way to do, yeah, cross, yeah, better cross, which cross number, cross 8 or cross 16, or uh, cross 8 or cross 16 or cross 4 divided by 8. Okay, sir, why we need to divide it by 8? Whenever you need the bandwidth in terms of bytes, in that time we divided by 8. Sir, I need a bandwidth in terms of bit, in that time no need to divide it by 8. Okay, yeah, that is the mega transfer. Yeah, the 1600 is the mega transfer per second. That is the transfer rate. In my side, transfer rate is present. We need to calculate the frequency. Okay, yeah, transfer rate divided by 2, 1600 divided by 2 is the frequency. What is the frequency? 800 megahertz. You only see the table, the 1000. Yeah, what is the my answer? The 800 megahertz. The 800 megahertz present or not in DDR3? Yeah, you only check. Yeah, 800 megahertz is present. Yeah, in that time you only check what is the data rate? 1600 mega transfer per second. Okay, in the same way, the data transfer rate is divided by 2 is the frequency. 800 nothing but 400. 1066 533 megahertz. Okay, next we calculate the bandwidth. Bandwidth. Bandwidth nothing but what is the formula of bandwidth? Transfer rate. What is the transfer rate? This is the transfer rate is 1600. 1600 mega nothing but 10 to the power of 6. Okay, next yeah, cross, whether this is cross 8, right? Cross 8. 8 divided by, I need a bandwidth in terms of bytes, so that reason we divided by 8. 8 cancel. What is the bandwidth? 1600 megabytes. That is the bandwidth. Megabytes per second. That is the bandwidth of this one, this card. What is this card? That is this card bandwidth. 1600 megabytes per second. What is the frequency? 800 megahertz. 800 megahertz. Okay, this way we calculate frequency and bandwidth and transfer rate, guys. Transfer rate of each DRAM card. This three formula is we can use by we calculate the frequency, transfer rate and bandwidth. If you have any doubt to calculate the frequency, transfer rate and bandwidth, guys, Ayush and Pushparaga, if you have any doubt.
And no, sir.
Yeah, okay. Yeah. Next topic is that is simple. The frequency nothing but is a transfer rate divided by 2. Okay, the one thing the initially one mentioned, right, that is not a frequency. 1600 nothing but that is not a frequency. That is the mega transfer rate. Okay, don't confuse. Okay, yeah, just mention formulas. That frequency, the frequency is equal to reciprocal of time also. Yeah, one thing in this scenario I didn't calculate time, right? The frequency is equal to 1600. Yeah, not 1600, 800, right? Yeah, 800 is equal to divided by 1 by time. What is the time? Time is equal to 1 divided by 800 megahertz. The frequency is megahertz. Yeah, the 1 divided by 800, right? Yeah, 1 divided by 800. Yeah, around 0.00125, 0.00125, right? 0.00125 divided by mega is nothing but 10 power 6. Okay, yeah, 10 power 6 mega is equal to 0.00125 divided by 10 power minus 6. Sorry, plus 6 we go to the numerator, in the time minus 6. Okay, in the time we can easily to convert nanosecond, so that reason 0.125. Yeah, 1 2 0 0 1 to 5, right? 1 2 3 1.25.
125,
Yeah,
1.25 nano.
yeah, 1.25 nanosecond. That is the time. That is the time between the one clock cycle. That is the time when between the one clock cycle. Okay. Yeah, this way we can calculate, guys. Yeah, yeah. The time frequency formula is equal to 1 divided by the reciprocal of time, and then yeah, in this scenario we calculate the time. The frequency is equal to, the frequency is equal to 800 megahertz. 800 megahertz, and then the time is equal. Yeah, we need to calculate time, right? Yeah, time. In the time, the time is equal to 1.25 mega. Yeah, 1.25 nanosecond. Yeah, nanosecond. Yeah, next data, the transfer rate. Transfer rate of formula is equal to double of frequency. Double of frequency. What is the frequency in this scenario? The frequency is equal to 800 800 megahertz. 800 megahertz into 2, nothing but 1600 mega transfer per second. 1600 mega transfer per second. Yeah, next formula is bandwidth. Bandwidth is equal to transfer rate. Transfer rate is equal to cross Junction cross divided by 8. What is the unit? Nothing but mega. Yeah, bytes. Okay. Next we calculate the transfer rate is 1600 mega into, yeah, 10 power plus 6. Yeah, 8 divided by 8. Yeah, in this time 1600 megabytes per second. 1600 megabytes per second. Yeah, this way we can easily to calculate the bandwidth, transfer rate, frequency, and time. Okay. What is that example? That example is 4 GB cross 8. 4 GB cross 8 PC 1600. Nothing but 1600 megahertz, 4 GB capacity. That cross is cross 8. Okay. This way we can easily to calculate the frequency and bandwidth, guys. Okay. If you have any doubt in this part,
No doubt.
No, sir.
yeah, better. Yeah, that is the first part of this today's session, guys. Okay, the first part of this the today webinar. Yeah, 1 minute.